Look at the dashboard of your hybrid. You think you're driving a marvel of modern fuel efficiency. But right now, a single innocent-looking button is quietly draining your high-voltage traction battery up to 3 times faster every single summer. And the worst part? You have absolutely no idea it's happening. This isn't a factory defect. It's not a secret recall the manufacturer is trying to hide. It is one specific everyday air conditioning setting that forces your electric compressor to work so brutally hard that your hybrid battery cycles relentlessly. Your gasoline engine fires up far more than it ever should, and your fuel economy plummets by double digits. We aren't talking about a minor, theoretical drop in efficiency here. Real thermal data from controlled laboratory testing confirms that choosing the wrong ventilation mode increases air conditioning power consumption by over 6% of the total vehicle energy. In extreme summer heat, that number climbs even higher. Think about that for a second. More than 6% of your car's entire energy budget is being vaporized by a single button press. The system is literally fighting against itself, and you're paying the price at the pump and in long-term battery degradation. The real kicker is that the engineers actually built a much smarter, highly sophisticated climate control system into your car to prevent exactly this kind of waste. But almost nobody uses it because the dealerships don't explain it. The owner's manual buries it in dense text, and frankly, nobody knows it exists. Today, we are pulling back the curtain. I'm going to walk you through the precise setting that's causing the damage, break down exactly what the laboratory thermal data proves, and show you a simple fix you can implement in under 5 seconds to protect your investment. Let's get right into the heart of the problem. The setting that causes all this unseen damage is the fresh air intake mode on your climate control system. You know the button I'm talking about, the one with the little icon showing an arrow pointing from the outside into the silhouette of a car. It dictates whether your air conditioning system continuously pulls in hot, humid air from the environment, or recirculates the already cooled air inside the cabin. Most drivers press it without a second thought. Some leave it on fresh air permanently because they believe it keeps the cabin from getting stuffy, or because they think it's healthier. But on a hybrid vehicle, selecting fresh air mode is the single most energy-destructive decision you can make on a hot day. It directly accelerates your hybrid battery's demise in a way that most owners never connect to their falling miles per gallon numbers. To understand why this is such a massive deal, you have to understand how a hybrid differs from the conventional, gas-powered cars we've been driving for decades. In a traditional gasoline vehicle, the air conditioning compressor is a mechanical unit driven by a rubber belt attached directly to the engine's crankshaft. The energy cost of running that compressor is largely hidden inside the overall load of the engine. Sure, you might feel a slightly sluggish throttle response or notice a minor dip in your fuel economy, but the engine is already spinning anyway to move the wheels. On a hybrid, the rules of the game are completely rewritten. The air conditioning compressor is completely detached from the engine. It is a high-voltage electric compressor powered directly by your high-voltage traction battery pack. The exact same battery pack responsible for spinning the electric motors and driving the vehicle down the road. Every single watt of electricity that the compressor consumes is a watt taken directly away from your electric drivetrain. When you force that electric compressor to work harder than necessary, you are actively bleeding power from the battery. The battery's state of charge drops like a stone. And when that happens, the hybrid's electronic control unit has no choice but to fire up the gasoline engine solely to act as a generator and charge the battery back up. That means more fuel burned, more unnecessary engine runtime, increased mechanical wear, and a hybrid system that is constantly forced to cycle between rapid discharging and aggressive charging instead of gliding efficiently down the road the way the engineers intended. Let's look at what the scientific thermal data actually reveals about this phenomenon. In a peer-reviewed study analyzing hybrid vehicle energy consumption, researchers tested different cabin ventilation modes under strictly controlled laboratory and real-world road conditions. They utilized the standard federal test procedures specifically designed to simulate hot weather city driving with the air conditioning running at full capacity. The findings were absolutely striking. When the vehicle's climate control was set to fresh air mode, the electric air conditioning compressor consumed a staggering 34.5% of the total vehicle power. Let that number sink in. Over a third of the car's total energy was going just to cool the cabin. However, the moment the system was switched to recirculation mode, that power consumption dropped down to 28.4%. That is a massive 6.1% reduction in total vehicle energy usage, achieved by doing nothing more than changing a single setting on the dashboard. On a hybrid, that 6.1% savings isn't just an abstract laboratory statistic. It translates directly into real-world endurance for your traction battery, fewer engine interventions, and a dramatic extension of your battery pack's overall lifespan. To visualize how this plays out on the blacktop, imagine you're sitting at a red light on a blistering 95-degree day. Your hybrid is sitting in electric vehicle mode. The gasoline engine is completely silent, and the cabin is beautifully cool. If you are running in recirculation mode, the electric compressor is working with air that is already close to your target cabin temperature. It spins at a low, highly efficient speed, draws minimal current, and the battery's state of charge remains stable. But if you have that button set to fresh air mode, the system is continuously drawing in 95-degree air from the outside, passing it over the freezing evaporator core, and attempting to cool it down to your desired temperature from scratch, over and over again. The compressor has to spin at maximum velocity, screaming under immense load and pulling massive amounts of current straight out of the high-voltage battery. Within just a couple of minutes, the vehicle's computer detects that the battery is draining dangerously fast and forcefully kicks the gasoline engine awake just to keep up with the electrical demand. That entire engine start cycle was completely avoidable. Now multiply that single stoplight by every red light, every traffic jam, every parking lot wait, and every drive-through line you encounter across an entire summer. You quickly begin to see the massive cumulative cost of this one bad habit. Even data from the U.S. Department of Energy explicitly states that under very hot conditions, air conditioning use can slash a vehicle's fuel economy by more than 25%. And they note that this penalty can be significantly larger on a percentage basis for hybrid and electric vehicles. Because the energy is drawn directly from the traction battery rather than an engine belt, the penalty is magnified in ways the average driver never realizes. Independent automotive testing backs this up completely, showing that hybrids experience up to a 9.3% spike in fuel consumption during city driving when the climate control is pushed to its absolute limits. And city driving is precisely where a hybrid is supposed to shine and save you the most money. But the true danger of ignoring this setting goes far deeper than just a painful hit to your fuel economy. The real silent killer here is the hidden mechanical toll it takes on the most expensive component in your entire vehicle, the high-voltage battery pack itself. Every extra charge and discharge cycle you force upon that battery slowly chips away at its total service life. Hybrid batteries are engineered to operate within a very specific, carefully guarded state of charge window, typically hovering between 40% and 80% capacity. The vehicle's computer system constantly monitors this window to maximize longevity. When your electric compressor is forced to draw excessive, continuous power due to fresh air mode, the battery charge plummets toward that lower boundary at an accelerated rate. This forces the gasoline engine to engage, burning fuel to drive the generator and push the battery charge back up to the safe zone. That rapid drop and subsequent forced recharge constitutes a full, heavy battery cycle. Over thousands of miles of summer driving, these unnecessary cycles accumulate by the hundreds. Battery degradation is an irreversible, cumulative process. A battery pack that is forced to cycle 3 times more frequently during the hot months is quite literally aging 3 times faster during that period. You won't notice the damage today, next week, or even next month. The car will seem to run just fine. But down the road, around the 7th, 8th, or 9th year of ownership, when that battery pack is approaching the later stages of its designed operational life, those thousands of extra preventable cycles will be the exact tipping point. It will be the difference between a hybrid battery that still holds a strong charge and keeps you on the road, and a degraded pack that triggers a dashboard warning light and demands a massive $2,000 to $4,000 replacement. All because of a tiny button that was left in the wrong position day after day. What makes this situation so incredibly frustrating is that the manufacturers actually designed an incredibly intelligent defense mechanism directly into the vehicle's software. They knew the energy math, and they built the climate control system to automatically protect itself. If you pay close attention when you first start your hybrid on a hot day, the system will almost always default to recirculation mode automatically if the ambient temperature outside climbs past 75 degrees. The engineers programmed it that way specifically to minimize the load on the compressor and preserve the battery. The breakdown happens because drivers constantly override this automated logic. People get into the car, see the recirculation light on, and turn it off because they want an immediate blast of what they perceive as fresh air. They bypass the engineering safeguards without ever realizing they are actively sabotaging their own vehicle's efficiency and longevity. And that is just the tip of the iceberg when it comes to the hidden energy management systems built into your dashboard. There are hidden features, specific button combinations, and secret operational modes designed to slash your compressor's power draw by massive margins. Features that most owners inadvertently disable or completely misunderstand, leaving their batteries completely unprotected against the summer heat. If you want to stop bleeding fuel and protect your high-voltage pack from early retirement, you need to know exactly how these systems interact and the critical mistakes to avoid when the temperature spikes. Here's the fix most dealers won't mention. You don't need a toolbox, you don't need an automotive engineering degree, and you don't have to spend a single dime at a repair shop. The ultimate solution to stopping this massive energy drain and protecting your high-voltage traction battery is a simple 5-second correction in how you operate your climate control system, combined with unlocking 2 heavily misunderstood features already built into your vehicle. Let's break down the exact step-by-step process to maximize your hybrid's efficiency and stop those brutal battery cycles immediately. Step number 1 is a physical habit change before you even turn the key. When you approach your vehicle on a blistering summer afternoon, the air trapped inside your cabin isn't 95 degrees. It can easily rocket up to 140 or even 170 degrees Fahrenheit because of the greenhouse effect through the glass. If you jump in, crank the air conditioning, and expect the system to tackle that superheated air, the compressor is going to scream at maximum capacity regardless of your settings. The immediate fix is to roll down all your windows for just 30 to 60 seconds right as you start moving. Let the natural airflow flush out that pockets of trapped, superheated air. This drops the baseline cabin temperature by dozens of degrees in under a minute without drawing a single milliamp of electricity from your high-voltage battery. Step number 2 is sealing the cabin. Once that initial blast of heat escapes, roll the windows completely up. Now look at your climate control panel and immediately ensure that the recirculation button is active. This is the core fix. By forcing the system to recool the air that is already inside the car, you are handing the electric compressor an incredibly easy job. Each time the cabin air passes through the cooling coils, it gets colder and colder. The compressor quickly realizes it has met its target, drops its fan, and motor speeds down to a highly efficient whisper, and drastically slashes the current it pulls from your traction battery. Step number 3 is utilizing the secret weapon Toyota built into your dashboard, the SmartFlow or S-Flow feature. Look closely at your climate control cluster for a button labeled S-Flow or a symbol showing an airstream targeting only the driver's seat. When you press this button, you are telling the climate control electronic control unit to use occupancy sensors inside the vehicle. If you are driving completely alone, the system intelligently shuts off or severely reduces airflow to the front passenger seat and the entire rear seating area. Think about the physical reality of this. Instead of forcing that electric compressor to cool a massive, empty 50 cubic foot cabin, it only has to manage the small pocket of air directly surrounding your body. This drops the thermal load on the compressor by up to 50%. Less thermal load means less electrical draw, fewer engine start cycles, and immediate fuel savings. Step number 4 is aligning your driving mode with your climate strategy by using Eco Mode. Many drivers hate Eco Mode because they feel it makes the throttle pedal feel lazy or unresponsive. What they don't realize is that Eco Mode completely alters the programming of the air conditioning system. When Eco Mode is active, the computer automatically establishes a highly efficient floor for the cooling system. It limits the maximum speed the compressor can spin and manages the target temperature intelligently to prevent aggressive battery draining. If you set your thermostat to a freezing 64 degrees on a 90-degree day without Eco Mode, your compressor will destroy your battery's state of charge, trying to hit an impossible target. Eco Mode smooths out those demands, protecting your high-voltage pack from extreme power spikes. To see what a massive difference this makes in the real world, let's look at a common case that rolls into the workshop every single summer. A customer came in driving a standard, high-volume hybrid commuter car. They were deeply frustrated because their fuel economy had suddenly plummeted from an average of 50 miles per gallon down to the high 30s. And they noticed the gasoline engine was kicking on constantly at stoplights with a loud, aggressive revving sound. They were convinced the traction battery was failing, or that a major electronic component had broken down, and they were bracing themselves for a massive repair bill. I hooked up the diagnostic scanner and went into the live data streams while simulating a hot weather commute. The data told the story instantly. The driver had disabled Eco Mode, turned off the S-Flow system because they thought the reduced airflow meant the system was broken, and had manually selected Fresh Air Mode while setting the temperature dial to its lowest possible setting. The live data showed the electric compressor spinning at an astonishing 8,000 revolutions per minute, drawing over 3,000 watts of continuous power straight out of the high-voltage battery pack. The battery's state of charge was dropping like a stone every time the car stopped, forcing the engine to fire up repeatedly just to keep the car's electronics from shutting down. The fix didn't cost the customer a single dollar. I sat in the driver's seat, rolled the windows down to vent the cabin, turned on the recirculation mode, engaged the S-Flow system, and popped the car into Eco Mode. Within 5 minutes of driving, the live data on my scanner shifted completely. The compressor speed dropped from 8,000 RPM down to a highly efficient 2,000 RPM. The electrical power draw plummeted from 3,000 watts to less than 800 watts. The high-voltage battery state of charge stabilized beautifully, and the gasoline engine finally went silent at stoplights, staying off for extended periods. The customer left the shop with their 50 miles per gallon fully restored, completely blown away that a simple habit change could completely alter the behavior of their vehicle. But as simple as this fix is, you have to watch out for a few critical mistakes and common misconceptions that trip up even seasoned car enthusiasts. The first major mistake is the fear of stuffy air. Many drivers worry that leaving the system on recirculation mode permanently will cause the cabin air to become stale or cause the windows to fog up. Toyota's engineers already anticipated this. The system is designed to automatically introduce tiny, calculated percentages of fresh air behind the scenes, even when recirculation is active, ensuring proper oxygen levels without overloading the compressor. If you truly feel you need a blast of fresh air, the correct habit is to switch to fresh air mode for just 60 seconds every 20 minutes to completely flush the cabin, then immediately toggle it back to recirculation. The second, and perhaps most dangerous mistake, is messing with your gear shifter while idling. Many drivers have a bad habit of throwing their hybrid into neutral when they are sitting in a long drive-through line, waiting at a train crossing, or parking on the side of the road with the air conditioning blasting. They think they are relieving strain on the transmission. This is an absolute trap on a hybrid vehicle. The hybrid charging logic is specifically programmed to function only when the vehicle is in park or drive. When you shift into neutral, you completely disconnect the generator's ability to charge the high-voltage traction battery. If you sit in neutral with your air conditioning screaming on fresh air mode, The electric compressor will continue to brutally drain the battery, but the gasoline engine will be physically blocked from recharging it. The battery will drain down to dangerously low levels, forcing the vehicle into an emergency turtle mode or causing severe, permanent cellular degradation to the battery chemistry. Never, under any circumstances, idle your hybrid in neutral with the climate control running. The final misconception is assuming that setting the temperature dial lower makes the car cool down faster. It doesn't. Setting your hybrid's climate control to 62 degrees won't bring the cabin down to temperature any faster than setting it to 72 degrees. It simply tells the compressor to never stop running at maximum power. Trust the engineering. Set a reasonable temperature like 72 or 74 degrees. Turn on your recirculation button. Ensure S-Flow is active. And let the sophisticated computer system protect your hybrid battery the exact way it was designed to do from the factory. By mastering these simple climate control habits, you aren't just saving a few bucks at the gas pump this week. You are actively rewriting the lifespan of your hybrid's most critical asset. When you keep that electric compressor operating within its peak efficiency zone, you instantly slash thousands of unnecessary high-stress charge and discharge cycles away from your high-voltage traction battery pack. Over a few years of ownership, that translates directly into extended battery health, rock-solid fuel economy that doesn't plunge when the summer heat hits, and the absolute peace of mind that you won't be hit with a premature $4,000 battery replacement bill just as your car is getting broken in. You are taking control back from the wear and tear cycle that catches millions of oblivious drivers completely off guard. But if you want to truly maximize this baseline benefit and ensure your hybrid system stays bulletproof for the next 200,000 miles, there are a handful of complementary habits and maintenance checks that you need to integrate into your routine. Think of these as the supporting pillars to the climate adjustments we just locked down, the absolute first complementary check you need to perform. And you should do this before the peak of summer hits every single year, is inspecting your hybrid battery's dedicated cooling fan filter. Most people don't even know this filter exists because it isn't under the hood next to the engine. On almost every modern hybrid, the traction battery pack relies on cabin air to stay cool, drawing it in through a small vent located either underneath the rear passenger seats or along the side panels of the rear cabin structure. Right behind that grille sits a small mesh filter designed to catch dust, pet hair, and debris. If that filter gets choked out by dust, the battery pack cannot breathe. Its internal temperature will skyrocket, and when a hybrid battery gets hot, its internal resistance goes through the roof. This forces the battery to work exponentially harder to absorb and discharge energy, amplifying the exact thermal stress we are trying to prevent with our climate settings. Check that filter, vacuum it out, or replace it for a few bucks. It is the cheapest insurance policy you can buy for your hybrid drivetrain. The second crucial habit is maintaining your cabin air filter. Because we are now heavily relying on the recirculation setting to protect our high-voltage compressor, the air inside your vehicle is passing through that cabin filter continuously. A clogged, ancient cabin filter restricts the overall volume of airflow passing across the air conditioning system's evaporator core. When airflow drops, the temperature sensors tell the computer that the cabin isn't cooling down efficiently, which forces the electric compressor to ramp up its rotational speed and draw more current to compensate for the restriction. Changing your cabin filter every 12 to 15,000 miles isn't just about breathing clean air. It physically reduces the mechanical and electrical load on your high-voltage electrical architecture. Now, while you are implementing these optimization strategies, you do need to be fully aware of a few inherent trade-offs so you aren't caught off guard by how your vehicle responds. The biggest trap enthusiasts fall into is toggling their vehicle into sport mode because they want a sharper, more responsive throttle feel when merging onto the highway or navigating city traffic. There is absolutely nothing wrong with enjoying a little extra performance out of your machine, but you have to understand the hidden energy tax that comes with it. Sport mode alters the hybrid system's baseline logic. It instructs the gasoline engine to run far more frequently to ensure that the electric motors always have an instantaneous reservoir of maximum electrical power available. Simultaneously, it deselects the aggressive energy-saving protocols of the climate control system. If you run sport mode continuously in 95-degree heat while expecting your fuel economy numbers to remain flawless, you are fighting a losing battle. The computer will actively override your efforts to keep the engine off at stoplights. The smart move is to use sport mode contextually when you actually need the mechanical urgency. Then immediately pop the vehicle back into eco mode to let the climate management and battery protection systems take the wheel during the mundane stretches of your commute. Another minor trade-off to keep in mind is that during intense heat waves, running your system in strict recirculation mode can occasionally lead to a slight buildup of humidity inside the cabin if you have a full car of passengers. If you ever notice the air feeling a bit heavy, or the edges of your windows starting to track moisture, don't panic and don't permanently disable your settings. Simply use the override strategy we discussed. Drop the front windows an inch, or switch to fresh air mode for exactly 60 seconds to clear the cabin atmosphere, then button it back up. You retain 99% of your battery-saving efficiency while maintaining total cabin comfort. What all of this really comes down to is situational awareness and refusing to let automated marketing claims dictate how you maintain your property. Dealerships want you to believe that modern hybrids are completely hands-off appliances that require zero thought from the driver. They sell the illusion of a vehicle that optimizes itself perfectly under every single condition without human intervention. But as someone who stands on the concrete floor of a workshop day after day, looking at the real-time data and the component failures that land on my lift, I can tell you flat out that the system relies on you to give it the right parameters to succeed. You now possess the insider knowledge that places you light years ahead of the average vehicle owner. You know exactly how that high-voltage scroll compressor behaves under load. You understand the precise energy cost of the fresh air intake mode. And you know how to leverage S-Flow and eco-programming to build an impenetrable shield around your traction battery pack. Implementing these tweaks doesn't take away from your driving experience. It elevates it. It transforms you from a passive passenger blindly paying the systemic costs of premature wear into an active, empowered operator who knows exactly how to make their machine run cleaner, harder, and longer than the manufacturer ever advertised. Take these steps seriously. The next time you step inside your hybrid on a scorching summer day, don't just mindlessly turn the key and let the dashboard do whatever it wants. Roll those windows down, flush the heat, seal the cabin, lock in that recirculation button, engage your smart flow sensors, and watch your system glide effortlessly the way it was truly engineered to do. Look after your machine.